In mathematics, a matrix is a rectangular array or table of numbers with elements or entries organized in rows and columns. Several basic operations can be applied to matrices. In this video, we will study matrix addition and subtraction, matrix multiplication, and scalar multiplication. Hello everyone, welcome to my channel. My name is Rafael. I am an electrical engineer and bilingual teacher of mathematics and physics from Brazil. And in this video, I would like to have a conversation with you on matrices. And for this purpose, I selected 7 exercises. Let's go to the first exercise. Exercise number 1 says, let A, B, and C be 3 2x2 matrices in which C is equal to 3A minus 2B. Find the matrix C. Okay, my friends, this is the exercise. Let's go to the solution. The exercise provided us these 2 matrices A and B and said that the rule of formation of C is 3 times A minus 2 times B. Okay? And the exercise said that A, B, and C are 3 2x2 matrices. Consequently, C will also be a 2x2 matrix. C will be C11, C12, C21, and C22, okay? This is how matrix C is. Let's go, let's find matrix C. We need to use this rule of formation here. C will be equal to 3 times matrix A minus 2 times matrix B. Alright? Firstly, we carry out scalar multiplication. We are going to multiply the matrices by these scalars, 3 and negative 2. Thus, matrix C will be 3 times 2 is 6, 3 times negative 1 is negative 3, 3 times 3 is 9, 3 times 4 is 12. Alright? Plus, observe that when carrying out scalar multiplication, we multiply every entry of the matrix by the scalar, okay? Negative 2 times 5 is negative 10. Negative 2 times 3 is negative 6. Negative 2 times 2 is negative 4. And negative 2 times 6 is negative 12. Now that we've performed scalar multiplication, we are going to carry out matrix addition. When performing matrix addition, we sum the corresponding entries of the matrix A11 with B11, A12 with B12, A21 with B21, and A22 with B22, okay? Six plus negative 10 is negative 4. Negative 3 plus negative 6 is negative 9. 9 plus negative 4 is 5. 12 plus negative 12 is 0. Okay, my friends? And this is all for exercise number 1. A very simple exercise just to introduce us to the topic of matrices. Let's go to the next. Let's go to exercise number 2. Okay, my friends, let's go to the next exercise. Let's go to exercise number 2. Exercise number 2 says, let A be a 3 by 3 matrix in which Aij is equal to I plus j if I is less than j, and Aij is equal to 3i minus j if I is greater than or equal to j. Then the question, calculate the sum of the entries of A. Alright, my friends, this is the exercise. Let's go to the solution. As matrix A is a 3 by 3 matrix, it can be written as, this is the standard form of a 3 by 3 matrix, alright? And the entries will be, if I is less than j, Aij is equal to I plus j, and if I is greater than or equal to j, Aij is equal to 3i minus j, alright? Firstly, we need to identify the entries of A for which I is less than j. They are these. And secondly, the entries of A for which I is greater than or equal to j, and they are these, okay? Now, we simply use the rules of formation. Firstly, for I less than j. The first one is this. A12 will be equal to, when I is less than j, we use this rule of formation, I plus j. Then it is 1 plus 2 equal to 3. The next one, A13 is equal to 1 plus 3, which is equal to 4. And the last one, A23 equal to 2 plus 3, and this is equal to 5. Now for entries in which I is greater than or equal to j, for I greater than or equal to j. The rule of formation is this, Aij is equal to 3i minus j. The first one is A11, and this is equal to 3 times 1 minus 1, and this is equal to 3 minus 1 is 2. The second one, A21, will be equal to 3 times 2 minus 1, and this is equal to 6 minus 1 is 5. The next, A22 will be equal to 3 times 2 minus 2, and this is equal to 6 minus 2 is 4. A31, 3 times 3 minus 1, and this is equal to 9 minus 1 is 8. A32, 3 times 3 minus 2, and this is equal to 9 minus 2 is 7. And the last one, A33 is equal to 3 times 3 minus 3, and this is equal to 9 minus 3, 6. Now that we have all the entries of matrix A, we calculate what the exercise wanted us to calculate. The exercise wanted us to calculate the sum of the entries of A. Alright? We simply sum them all. Okay? It will be 3 plus 4 plus 5. Okay? 3 plus 4 plus 5 plus 2 plus 5 plus 4 plus 8 plus 7 plus 6. Okay? Isn't it? 3, 4, 5, 2, 5, 4, 8, 7, and 6. And this sum is equal to 44. Alright, my friends, this is the solution of exercise number 2. Let's go to the next. Let's go to exercise number 3. Exercise number 3 now. 3 people whom you call 1, 2, and 3 telephone each other a lot. In the matrix, each entry Aij represents the number of calls I made to J in the past week. The question: who received the most calls? Okay, my friends, this is the exercise. Let's go to the solution. The matrix is this, and as the exercise said, each entry Aij represents the number of calls I made to J. Okay, my friends? The exercise informed us that the entry Aij represents calls made by I to J. Thus, let's go to the solution. For person number 1, person 1. The sum A11 plus A12 plus A13, which is equal to A11 is 0, A12 is 7, A13 is 9. This sum, which is equal to 16, represents the number of phone calls made by 1 to J. A11 represents the number of phone calls made by 1 to 1. As you cannot call yourself, it is 0. A12 represents the number of phone calls made by 1 to 2, to person number 2. And A13 represents the number of phone calls person number 1 made to person 3, okay? So, person 1 called 16 times. So, this number represents calls made by 1. Likewise, A11 plus A21 plus A31 represents, this sum represents the number of phone calls received, not made, received by 1. A11 is 0. You cannot receive a phone call by yourself. That's why it is 0. A21 is this. It means that person 2 called person 1 8 times, plus 6. This 6 means that the person 3 called the person 1 6 times. And this is equal to 14 calls received. Received by 1. 16 calls made by 1 and 14 calls received by 1. We are going to do the same for person 2 now. The sum A21 plus A22 plus A23 represents the number of phone calls made by 2. Person number 2 made these phone calls, and this is equal to 8, A21, 0, A22, and 11, A23, okay? 8 plus 0 plus 11. This 8 here represents the number of phone calls made by person 2 to person 1. This 0 represents the number of phone calls made by person 2 to person 2. As you cannot call yourself, it is 0. And 11 times person 2 called person 3. Alright? And this is equal to 19 calls made by 2. Similarly, A12 plus A22 plus A32 represent the number of phone calls received by person 2. A12 is here, A22 is here, and A32 is here. Person 1 called the person 2 7 times, 0 because you cannot receive a phone call by made by yourself, and 12 times represents the number of phone calls received by person 2 made by person 3. So it is 7 plus 0 plus 12, and this is equal to 19. 19 calls received by 2. And lastly, for person 3, A31 plus A32 plus A33. A31 is this number of phone calls made by 3 to person 1. A32, the number of phone calls made by person 3 to person 2. And 0 because you cannot call yourself. Alright? Then it is equal to 6 plus 12 plus 0, and this is equal to 18 calls made by 3. And to finish, we calculate the number of phone calls received by 3. A13 plus A23 plus A33. A13 represents the number of phone calls made by 1 and received by 3. A23 is the number of phone calls made by 2 and received by 3, and this is 0, alright? Then it is 9 plus 11 plus 0, and this is equal to 20 calls received. By 3. Alright, my friends, now we have to go back and see the question. What was the question? The exercise asked us who received the most calls. Observe here that it is 3. 20. By inspecting the results, we can state that person 3 received the most calls. 20 calls. Alright, my friends, this is all for exercise number 3. Let's go to exercise number 4. Exercise number 4 now. 2 students took 5 tests. The matrix shows in each entry Aij the grade of student I in test J. The question: by how much was the average grade of student 2 higher than the average grade of student 1? Okay, my friends, this is the exercise. Let's go to the solution. The exercise stated that the entry Aij represents the grade of student I in test J. In this way, for instance, A13 represents the grade of student 1 in test 3. But the exercise wants us to compare the averages. So firstly, we calculate the averages. The average grade of student 1 will be A11 plus A12 plus A13 plus A14 plus A15. The exercise said that they took 5 exams. The average is this divided by 5. We sum the entries of the first row. 7 plus 5 plus 6 plus 3 plus 9 divided by 5. And this average is 6. Similarly, we proceed for student 2. We sum the entries of the second row. A21 plus A22 plus A23 plus A24 plus A25. Student 2 took 5 exams as well, so the average is the sum of the grades divided by 5. And this is equal to, as I said, we sum the entries of the second row. 6 plus 7 plus 4 plus 8 plus 6 divided by 5, and this is equal to 6.2. What is the conclusion that we get? As the average grade of student 2 was 6.2 and the average grade of student 1 was 6, the average grade of student 2 was 0.2 higher than the grade of student 1. The exercise wanted us, the question was, by how much was the average grade of student 2 higher than the average grade of student 1. So it is 6.2 minus 6, and this is equal to 0.2. Okay, my friends, and this is the solution of exercise number 4. Let's go to the next. Exercise number 5. Consider these two matrices A and B. The question, letter A, what is the sum of the squares of the entries of matrix C equal to A times B? Alright, my friends, this is the exercise. Let's go to the solution. To solve this problem, it is necessary to note that the multiplication of two matrices is possible only if the number of columns of the first matrix is equal to the number of rows of the second matrix, okay? Observe that A is a 2 by 3 matrix. A is a 2 by 3 matrix, which means that A has 2 rows and 3 columns, and observe that B is a 3 by 2 matrix, which means that B has 3 rows and 2 columns, okay? And the condition for multiplication is that the number of columns of A has to be equal to the number of rows of B. If this condition is verified, then multiplication is possible, okay? Now that we know that this multiplication is possible, we have to inspect the order of C. C will have the same number of rows of the first matrix and the same number of columns of the second matrix, okay? Now that we know that C is a 2 by 2 matrix, we write it here. C, C11, C12, C21, and C22, okay? Now let's calculate the entries of matrix C. C11. C11 will be obtained from the multiplication of the entries of row 1 of the first matrix by the entries of the first column of the second matrix, okay? It is going to be A11, this, times this, which is B11, plus A12 times B21 plus A13 times B31. Okay? C1, 2 now. C12 is going to be obtained from the multiplication of the elements or entries of the first row of the first matrix with the entries of the second column of the second matrix, okay? Then it is going to be A11 times B 12, A11 times B12 plus A12 times this B22, A13 times B32. Okay? This with this, this with this, and this with this, okay? this is this is B1, 2, this is B2, 2, and this is B3, 2. C21 is going to be obtained from the multiplication of the entries of the second row of matrix A by the entries of the first column of matrix B, okay? So it is going to be A21 times B11 plus A22 times B21 plus A23 times B31. And lastly, C22. C22 is going to be obtained from the multiplication of the entries of the second row of matrix A with the entries of the second column of matrix B, okay? In this way, C22 is going to be A21 times B12 plus A22 times B22 plus A23 times B32. If we take every entry, all right, and substitute here in this addition and multiplication, we find that C11 is 0, C12 is 0, C21 is 0, and C22 is 0, okay? So, matrix C is composed of zeros. Zeros only. Zero, 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 and 0. And this is the solution of letter A. Now let's go and work on letter B. Letter B asks us, what is the order of matrix D equal to B times A? Let's go to the solution. Observe that for this product to be possible, the number of columns of B has to be equal to the number of rows of A. Thus, this product here is only possible if the number of columns of the first matrix is equal to the number of rows of the second matrix. B is a 3 by 2 matrix and A is a 2 by 3 matrix. Observe that the number of columns of the first matrix has to be equal to the number of rows of the second matrix. When this condition is verified, we have a matrix. This product is possible, okay? We have a matrix that results from this product. And matrix D will have the same number of rows of the first matrix, the same number of rows of the first matrix, 3, and the same number of columns of the second matrix, okay? And in this way, we discovered that the order of D is 3 by 3. The condition is this: the number of columns of the first matrix has to be equal to the number of rows of the second matrix for this product to be possible. And after understanding that the product is possible, we assess the order of D. D will have the same number of rows of the first matrix and the same number of columns of the second matrix. Thus, D is a 3 by 3 matrix. Okay, my friends, and this is all for exercise number 5. Let's go to the next. Let's go to exercise number 6. Exercise number 6. Let A be a 2 by 3 matrix such that A is this matrix. Find the matrix B equal to A times the transpose of A. Okay, my friends, this is the exercise. Let's go to the solution. By definition, the transpose of a matrix is generated by converting each row of the original matrix into a column. In that sense, if A is this, the transpose of A will be produced by converting its rows into columns, okay? The transpose of A will be equal to, we are going to convert the first row into a column, 3, 0, and -2, and the second row is going to be converted into a column, 1, 4, -1. Okay? Now that we have A and the transpose of A, we need to assess whether this product here is possible, alright? Observe that A is a 2 by 3 matrix and the transpose of A is a 3 by 2 matrix, okay? For this product to be possible, the number of columns of the first matrix has to be equal to the number of rows of the second matrix. We see here that the number of columns of A is 3 and the number of rows of the transpose of A is 3. Then this product is possible, okay? We have matrix B resulting from this multiplication, and the number of rows of B is going to be the same of the number of rows of the first matrix, and the number of columns of B will be the same number of columns of the transpose of A, alright? Then we have this, matrix B is a 2 by 2 matrix, okay? Then matrix B is gonna be B11, B12, B21, and B22, alright? This is matrix B resulting from the multiplication between A and the transpose of A. All we need to do now is to find B11, B12, B21, and B22, okay? Let's go, let's do it. And this multiplication is going to be performed in this way. We are going to multiply rows of the first matrix with the columns of the second matrix, okay? B11 is going to be obtained from the multiplication of the first row of the first matrix with the first column of the second matrix, okay? It is going to be 3 times 3 plus 0 times 0 plus negative 2 with negative 2, okay? And this is equal to 13. B12 now. B12 is going to be obtained from the multiplication of the first row of the first matrix with the second column of the second matrix. Then it is going to be 3 times 1 plus 0 times 4 plus negative 2 times negative 1. And this is equal to 5. B21 now. B21 is going to be obtained from the multiplication of the second row of the first matrix with the first column of the second matrix, okay? We are going to multiply this by this. It is then 1 times 3 plus 4 times 0 plus negative 1 times negative 2. And this is equal to 5 as well. And lastly, B22. B22 is going to be obtained from the multiplication of the second row of the first matrix with the second column of the second matrix. We are going to multiply this by this, okay? It is 1 times 1 plus 4 times 4 negative 1 times negative 1. Okay? And this is equal to 18. Consequently, our matrix B resulting from the multiplication of A with the transpose of A is this. Thirteen, 5, 5, and 18. Okay? This is matrix B. Alright, my friends, this is all for exercise number 6. Let's go to the next. Alright, my friends, let's go to the last exercise. Let's go to exercise number 7. Let A be this 2 by 2 matrix. It is known that the sum of the entries of matrix A squared is equal to 11. Then, what is the value of x? Alright, my friends, this is the exercise. Let's go to the solution. Let's call C equal to A squared, okay? C is equal to A squared. C is going to be a 2 by 2 matrix as well because A is a 2 by 2 matrix. Then C composed of elements such as C11, C12, C21, and C22 is going to be obtained from the multiplication of A by itself. 2, 1, negative 1, and x. 2, 1, negative 1, and x. Okay? We are going to multiply A by itself, and the result is matrix C. Alright, let's work on each element of C one at a time. C11 is going to be obtained from the multiplication of the first row of the first matrix with the first column of the second matrix. Okay? This row here times this column here. Okay? Thus, it is equal to 2 times 2 plus negative 1 times 1. And this is equal to 2 times 2 is 4. This is negative 1. 4 minus 1 is 3. C12 is going to be obtained from the multiplication of the first row of the first matrix with the second column of the second matrix. This row here times this column here, okay? It is 2 times negative 1 plus negative 1 times x. Okay? And this is equal to negative 2 minus x. C21 now. C21 is going to be obtained from the multiplication of the second row of the first matrix with the first column of the second matrix, okay? This row here with this column here. It is equal to 1 times 2 plus x, 1 times 2 plus x times 1. C22 now. C22 is going to be obtained from the multiplication of the second row of the first matrix with the second column of the second matrix, okay? 1 times negative 1 plus x times x. And this is equal to negative 1 plus x squared. The exercise stated that the sum of the elements of C is 11. Consequently, 3 plus negative 2 minus x plus 2 plus x plus negative 1 plus x squared has to be equal to 11. Three minus 2 minus x plus 2 plus x plus negative 1 plus x squared equal to 11. And in the end we find that x squared is equal to 9, whose roots are x1 equal to 3 and x2 equal to negative 3. We have two values for which this is true, okay? The condition is the sum of the elements of a squared is 11. When we calculate a squared, the only possible solution is this: x equal to 3 and x equal to negative 3 for the sum to be 11. Alright, my friends, and this is all for this video. I hope you enjoyed it and learned from it. I am a teacher, guys. If you want to book a lesson with me, use my WhatsApp number. Goodbye!